routing project that we've been working on at LinkedIn. Um, we've named it Unified ATS Routing, just for lack of better name. Today's agenda is basically just go over what ATS currently offers and what are the gaps that we see in it that we would like to address with this new routing solution we have, and various use cases where it is useful. So I'm sure everyone is familiar with this. These are the current constructs that we have in ATS that can do routing, basically remaps, various forms of remaps, map, regex map, with port, reverse map, redirect, regex redirect, etc. And then any other requirements we have with routing, today we do it using plugins. There's regex remap that can do path-based regexes and other query param-based regexes and stuff. Cookie remap that can do cookie-based routing. Header rewrite can do some form of routing. You can set redirects in it. You can short circuit things. You can change destination with that. And then other custom plugins that you may write in your own, deployments. We have a bunch of such plugins as well. So that's where the problem appeared for us, and that's where we think we should build something. So this is great. The issue or the gaps we have with these are that remaps are primarily path-based, path and host, or host. So you have to have either of these to do to do any routing. But of late, or especially with the move to cloud and microservices, there's so many use cases that we come into where you may want to do routing based on other factors. Like cookie remap already does one part of it based on cookie, but think of extending that to other custom scenarios, like maybe based on user agent, or maybe based on your location from where you're appearing, or maybe device type, like mobile may have a different use case, browser may have a different use case, things like that. So none of that is possible today without having to write a new plugin. And the issue with that is that when you write all these plugins, they tend to conflict. As you can imagine, there's so much overlap between all those, and then you have to manage the order. And we've often run into problems where we assume some behavior, but then some other plugin comes and changes that. And then it's so hard to debug that or even reason about that. Again, there's no built-in, ATS itself expects us to add logs and stuff. We don't have any built-in automatic way of troubleshooting problems if things go wrong in production. One other problem we've seen is that, or we often run into, is that we don't have a ramp support in ATS. You add a route, it's 100% applied. If it matches, it applies to 100% of the traffic. You don't have a way to say only apply to 1% of my traffic, 10% of my traffic, or whatever percentage you want, unless you write a plugin again. So this is where, like we were talking this morning about production testing of new builds and stuff, this is where if you had a way of controlling that ramp automatically through some built-in function, then we could actually be more bold in rolling out new builds and start trickling traffic to it, and depending on the confidence, keep ramping up, things like that. So all these are various requirements we often talk about, and the general approach today has been to write a new plugin for each scenario you come into, and then you run into this plugin ordering issues. And when you have plugins, then there's order issues between global plugin and remap plugin and stuff like that. So other use cases where we often need to write custom routing solutions is if you want to shard. If you have this giant service that we started off maybe years ago as a monolith, but then with the move to microservices, the services team would start breaking that into multiple endpoints, like with each endpoint doing different things, again based on various criteria, whether it's location or user agent or other forms of custom headers or URL params or whatever you name it. But to do that again, it would again mean writing new plugins. Then canarying. Canarying is again one other requirement we talked about this morning, to roll out new builds, to have more confidence on issues. If you had a way of canarying, by canarying I mean sort of like A/B testing, where you send equal traffic to two versions of your deployment, equal sized deployment, and then compare the metrics. We could have tests and we could have a bunch of frameworks that can catch things, but it is never a replacement to production testing. Canarying allows you that ability to do production testing because it simply exercises all sorts of code paths that you can think of. And with the way you do canarying, you can actually do A to B, apples to apples comparison. So then again, debugging, troubleshooting, all of these are a problem with the current routing solution we have, or at least gaps in the current routing solution. So this is where we've been thinking about doing an API-based routing, where you create your route based on, you think of it as a model as a set of keys and a set of actions. The set of keys can be a combination of anything in the request, be it host, path, URL params, headers, cookies, geo, device type, whatever you want to identify, and that's abstracted. I mean, you can create any combination of that. There is no mandatory attribute that this has to be path-based or this has to be host-based. Those are the set of the keys, and that's the criteria that you use to filter the traffic. So basically, look for matching criteria on your incoming traffic. And the routing behavior itself is abstracted as actions. Actions can be simple routing, just like what Remap does today, or it can be an override routing, meaning this can be used for things like debugging or rolling out a new feature. So something like if the route was taking it to a service, like a service A, you want to send a percentage of that to some A prime, where you have your custom build or your new feature turned on or whatever. So this override route is on top of the existing route. Then a simple status-based thing, similar to how header rewrite does the redirect or redirect remap rules does the redirect. It can also be used to reject requests. If you find a security issue, for example, if all of a sudden there is a vulnerability that got exposed saying, if you get a request with this sort of header, it causes a crash in ATS or it causes a crash somewhere downstream, you could just add a rule to turn off or block the request at ATS. Oh, by the way, assumption is all of these rules are, all of these routing rules are created offline, but read dynamically by ATS, pulled and loaded dynamically by ATS. Config updates, again, we have config overrides today, but they're either remap driven or you have to write a plugin to do a more custom config setting. This would abstract that also into a rule form where your action is basically, for this matched traffic, I want this setting to be applied, something like that. Header operations, again, same thing. Canarying, load test. These are all different possible behaviors that you want to apply for the identified matched traffic. So the model looks something like this. You have your offline route server that offers this API. You use your API to create your routing rule. The routing server basically validates your rule. I'll talk about some validations we can do when creating the rule itself, and then pushes that to a data store. ATS polls those rules dynamically, or we could, I mean, that can be a custom implementation, whatever one wants. We could do a poll every few seconds, or that server can push down to ATS. And then once they're stored in ATS, ATS would start applying those rules, basically. So that's a high-level model. So some of the requirements for this routing model are, it should be self-serviceable. Actually, that's where we started off, that we don't have a way to make our routing configuration self-serviceable right now. It has to go through, like our SRE team has to babysit every route request that comes in to make sure it fits in the right place, it doesn't break something else, or it's actually even valid to even add that route and things like that. So with this model, if the routing server is able to automatically validate new routes, it can be made completely self-serviceable and let application teams configure their routes on the fly, basically. So to do the validation, an approach we are taking is to stream our, or we are considering is to stream our access logs to a central place in real time and tap onto that stream and try to find the matched impact of the new route over the matched set of logs. So basically, if you streamed the last 5 minutes worth of logs and look for someone's trying to create a new route that says, send all the Android traffic in India to this particular origin. So we could actually check in real time against the access logs to see how much Android traffic was there versus how much total traffic And you could actually come at a number saying this would impact maybe 10% of your traffic or 5% of your traffic. And then you can do further validation saying whether this traffic can be routed to this particular origin, whether it has enough capacity to handle this much traffic, or will it bring it down, that sort of validation. So that's one thing we could do. We could also detect rule conflicts because the route server also has a complete visibility of routes. It can also check if the new route that you're creating has already had a matching rule applied before, again, based on the streamed logs. And if there is a conflict or an overlap, the validation server could prompt back saying, hey, you're trying to hide an existing rule or overlap with an existing rule. Is this something that you really want to do? And let the operator take next action, or even block the attempt at that point and involve the traffic team to see whether it's a valid route or not. That's another detection that we can do. Other features that are needed from this API or that are expected from this API, it has to have a TTL. So every routing rule you create would have an expiration. It can be as simple as no expiration if it's a permanent route, or if it's a short-term testing rule, you could say 1 day, 2 days, whatever. Then another aspect of it is the dry run mode, which is basically you want to create this rule, but you don't want it to be active right now. You want to just create it, but also see the impact of it, meaning you could, from the real-time streaming, you could say this would impact so much traffic. And it's live. You can also start emitting metrics on it that this rule matched, but you're not actually applying the routing action. This is more for ease of operations and ease of rolling out new routes and stuff. Or if you discover a problem with the service, you could turn it off quickly as well. So that's the dry run mode. And the very key aspect of this is the ramp support, where in the rule you also specify some ramp factor. It could be, depending on your traffic volume, it could be parts per million or myriad or a percentage, depending on how. In one of the previous proxies that I worked, we used parts per million simply because our traffic volume was so much high. 1% would mean huge in terms of RPS, whereas parts per million you could still control as 0.01 or 0.1. So then there's a routing scope that you can define. So this is sort of like your deployment topology. If you have your deployment in 10 different fabrics or 10 different data centers, and you want to scope this to only a particular data center, or maybe even a subset of servers within that data center, this would allow you to do that. So that's the scope. So fallbacks is another very useful feature that we've been thinking about, where the idea is to automatically determine if this new route has caused problems and turn it off. Meaning, so you do the impact analysis, maybe you did it at the middle of the night, and maybe the traffic was low at that time and the route was valid, or maybe the analysis said, yeah, this particular origin has the capacity needed to serve this traffic. You created the route and activated it, but come the next day and peak hour, maybe the traffic went up, and that actually started swamping the origin server. So the fallback is where you track the error rates for each origin, and if that goes beyond certain threshold, and typically by errors I mean 5xx, connection errors and things like that, or maybe 503s. If it goes beyond the configured threshold, if the rule said turn it off, we would turn it off. And the fallback mode can be as simple as to simply turn it off and let it fall back to the previous behavior, or it could also specify a fallback origin, where you could say instead of sending here, send here, basically.
How does it get the data? Right, so you're monitoring this, but the rule execution itself has to look at whether the rate is too high.
Right. So the idea is to track error rates per origin in each server in a distributed fashion. And when you're applying the route, you pick the origin and you see the origin had an error rate.
So the plugin of the ATS itself is
correct, yeah. So it tries to correlate the error rate to a last made routing change, and if that change was made in, yeah, again, this is all tunable. If that change was made in the small, in last several minutes or several hours, you have the ability to turn it off, basically. But if that change was not, if there was no routing change made in the last 1 day, you don't do anything. It's an origin issue or whatever. So, yeah. And the rule also can store other context, things like which service owned this, or who created this, or other metadata that could be valid. If someone looks at the routing config, they can figure it out that this is for this particular purpose, and just to make more sense out of it. And in terms of how it should be designed, um, even though we have a bunch of keys that you can combine to create a rule, just for ease of implementation, we pick a primary key out of that. So and that primary key is predefined. You have a set of keys that in certain order where if they appear, that key is a primary key, marked as a primary key. So for example, if host is there in the criteria given, host becomes the primary key automatically. Or if it's a member ID, if your traffic has a login ID or a member ID based rule, that can be the more specific the key is, it can be picked as the more specific one is picked as the primary key, basically. And you order the rules as lists of those primary keys. And within the list, you have other keys added to it. And similar to how remap does longest match, this can be a longest match as well. You sort the rules in terms of number of keys, and the more the number of keys, you pick that one as the winner, basically. And yeah, and other aspects of it is longest match. Then composite or linked rules. That's basically where you want to avoid multiple matches. Remember how I talked about the ramp factor? So you could have, you're doing a load test for an origin where you want to send 1% of traffic for that origin to a particular single server where you're doing the test. And at the same time, if someone else wants another 1% to do something else, this allows you to do basically group related rules together to avoid multiple matches. So meaning, once you match the criteria, if it doesn't hit the 1% dice that you threw, you look for the next 1% and send it to this other origin if it's configured. So basically links rules together, so actions together for the same set of criteria. And this can be extended to many different features, like client-side load balancers. You could use the same traffic matching criteria to apply different sorts of QoS. Like you could throttle a different set of criteria can be throttled differently. For example, if you don't care as much about desktop traffic versus mobile traffic, you could apply higher throttling for desktop traffic and lower traffic for mobile. So basically some sort of prioritization. Retry handling as well. You could potentially use that to block retries from desktop or block retries from mobile. For example, if you ran into a problem where there's a rogue deployment in mobile and you want to turn off retries for mobiles, you could do that as well. And connection tuning, you could set different timeouts, different, basically again, comes down to QoS, different sorts of QoS. Could also extend this to response side, because so far I've talked about the request side manipulation, but you can also do the same thing on the response side as well. Error body templates. Today we have a giant generic error body templates, but you could customize them based on your user agent and stuff like that without having to write new code. Yeah, that's it. Any questions?
All these you're supposed to have.
Yeah. Right.
So there's something from Convo, universal data plane API.
Mm-hmm.
And so this is under the CNCF, and they were trying to solicit what is this key requirement
Mm-hmm.
that they can come up with a universal data plane API that crossover. So I think like whatever I hear you say here, like 60 or 70% is like similar to what you're
Yeah.
trying to do.
Yeah, possible. Yeah.
You might want to
Yeah.
align with instead of coming up.
So actually, this whole solution I have designed and implemented it in a different proxy, just not on ATS yet. But that happened before the Envoy thing that you talked about came over. And again, this is just general routing principles. How you want to match your traffic and split and apply different behavior. Yeah, I can take a look at that to see.
What's the granularity?
In terms of
Do I have to reload the open config rules and change them?
yes, yeah. So each rule you can edit them. I mean, there are certain parts of the rule that you won't be allowed to change. For example, the keys.
How do you identify the? So I've got
So-
50 rules. How do I pick
Oh, I see. So the API allows you to create a single rule at a time. So in terms of granularity, and we will have get APIs to query all the rules or query based on the keys that you want. Basically, you'll be able to search through the rules to figure out what you want to change. If you already know the rule, then that's even straightforward. There will be a rule ID associated with each rule, and the ID is a combination of is a hash of your keys, basically, to make sure it's unique.
That can be concurrently, so have them.
Right, right, yeah. And even that can be exposed as an API. Just give the keys and you get back the routing ID, or just give the keys and get the routing rule itself directly. Yeah. Yeah. So the API itself is a abstracted form. It can be anything that you want, and the engine is also pretty generic. Of course, the sorting and the parsing of the rule, that part is tied to the format that you pick. And I think we are exploring both YAML and JSON. Maybe end up doing JSON, but yeah, and that should be should not make a big difference. Any other questions?